So, hello students. Yesterday we have discussed about some of the introduction of the chapter and also try to get the formula for the average rate of reaction and instantaneous rate of reaction with the help of the graphical representation of the any given general equation. At the same time, we try to deduce how we can get the formula for the all those reactions which are having some different types of stoichiometric coefficients. So sequence, with the same sequence, we can start the topic with the same graphical representation one more time. I think you remember that. I think you remember that the graph. We can start the same thing one more time. Instantaneous rate of reaction and average rate of reaction actually including in the terms of disappearance of reactants and the terms of appearance of product. But now we are going to discuss about the rate of reaction and all those factors that govern the rate of reaction one by one. At the same time, at which fraction of the reactants, the more concentration of reactants, the actually rate of reaction depends. That will be come in the category of order of reaction and the idea how we can get the experimental value of the order of reaction. Before going to that point, we'll let us study first. This both the graph actually indicating, you can see the graph, nature of graph. This graph indicating at the beginning when time is 0, when the reaction initiate, the concentration of reactant is very high. With the passage of time, this is reactants, this is time, this is product, and this is time. With the passage of time, you can see the decrement, the disappearance of reactants is not so longer uniform. It's not so longer uniform, indicating the one of the very important factor, that is concentration. Students, you can see that in the beginning, when the concentration of reactant is very high, the concentration of reactant is very high, the disappearance of reactant is also very high. As the concentration of reactant decreases, the disappearance of reactant also decreases, and after a certain time, the graph indicating somewhat a parallel slope with the passage of time, indicating the reactants after a time, the disappearance of reactants will be in a no longer decrease value. The same opposite thing will be occur for the product condition. The appearance of product as well, as you can see in the beginning, the appearance of product is very high. As the passage of time occur, the appearance of product will be smaller, and the value of decrease indicating the process, the rate of production of product is actually also decreases. Actually, I am talking about the one of the major important factor that will decide the rate of reaction is a concentration. Because in the beginning the concentration is very large for reactants. The collision of particles, the particles that get collide together is very frequent. The frequency of collision is very high, and that is why there is more probability of appearance of product at the time, and that indicating in the beginning why rate of reaction is very high. With the passage of time, the rate of reaction decreases because the concentration of reactant also decreased. So the frequency of collision that will give a product also decreases, and that will affect inversely the rate of reaction. All these factors we have to be learned in the next section, that is called influencing factors, the factor influencing of the rate of reaction. But before going to that, I will choose some other question from the NCERT to try to solve how these rate of reaction formula can be introduced. In text question number 4.1 and 4.2, I am going to solve for you. For the reaction R equal to P, in text 4.1, the reaction R gives P, the concentration of reactant changes from 0.03 0.02 in 25 minutes. In 25 minutes, this is the sign of molarity, the mole per liter value. Calculate the average rate of reaction using units of time, both in minutes and seconds. So we have to be calculate the average rate of reaction. We are knowing that the average rate of reaction is equal to minus, even coefficient is not there, so there will be minus delta reactants upon delta T. So this will be give you value. Delta R means the difference of final value and initial value. The difference of final and initial will give you a minus 0.01 value, 0.02 and 0.03. That will give you a minus 0.01. And the time duration during this value change is 25 minutes. So you can calculate the value in the terms of positive. This will give you a positive value. This will give you a positive value. You can see the condition. The 10 to the power minus 2. 10 to the power minus 2 now. So when 1 into 10 to the power minus 2 divided by 25, there will be again the condition of, you can solve the value, which will give you 1 upon 25 into 10 to the power minus 2. 1 upon 25 into 10 to the power minus 2 mole per liter minute inverse. So the average rate of reaction for this given condition is 1 by 25 into 10 to the power minus 2 mole per liter minute inverse. The same answer you can calculate in the terms of second, because they are asking about in the second also. For second you have to be divided by 60 only. So the same value can be converted into second inverse by just dividing into 60. By just dividing into 60. Is it okay? We have to be divide 60 or we have to multiply 60? Anyone? Can we divide or multiply? Minute inverse and second inverse. So we have to be divided by 60. That will give you a value of average rate of reaction in the terms of second. The time inverse value, that is second here. The next question is 4.2. In the reaction 2A gives a product 4.2. The 2A gives our product. The concentration of A decreases from 0.5 mole per liter to 0.4 mole per liter in 10 minutes. Calculate the rate during this interval. So the rate of they are asking about the average rate of reaction because the time duration is very large. So this will be minus 1 by 2. You can see now there is a coefficient 2 with a reactant, so that will be reciprocal during the calculation of average rate of reaction. As we are knowing about, whenever the coefficient present, that will be just reciprocal. So this will be 1 by 2. The negative sign because of in the terms of reactants. So formula is minus 1 by 2 delta A upon delta T. Delta A value that will give you a minus 1.1. Delta T 10 minute. The answer will come in the minute inverse value. So you can solve the value. This will give you a plus 1 by 2 10 to the power minus 1 then 10 to the power minus 2. So the answer will be 1 by 2 into 10 to the power minus 2 mole per liter minute inverse. You can calculate the same value in the terms of second inverse also. So this is the method how you can calculate the formula value of average rate of reaction for any given type of process. If the coefficient is given, that will just be a reciprocal during the calculation. Negative sign always give you a positive value for the average rate of reaction because the rate is always come in the positive sign. Okay, now we can discuss about the factors influencing rate of a reaction. Let's discuss one by one the factors influencing rate of reaction. First, nature of reactants. Size of reactants. State of reactants. Concentration of reactants. Solvent used. Temperature. Pressure. Electromagnetic radiations. Intensity of light. Intensity of light and some more factors is there, I think 9, 10. Catalyst. These are some 10 factors are there. Still I think 1 or 2 factors remain, I think. Nature of reactants, size of reactants, state of reactants, concentration of reactants, solvent used or not used, temperature, pressure, radiation if we are used, intensity of light and catalyst. These are some major factors that always decide the rate of reaction. Even beside these 10 factors, 1-2 more factors are there, I think. 1 or 2 more factors are there, like activation energy value, the excited complex formation, the frequency of collision. These are the some beside factors that may include under catalyst topic. But these are the major factors. Okay, we will discuss one by one about these 10 factors. We will discuss about one by one these major 10 factors. Let us discuss from the starting nature of reactants. Nature of reactants means the reactants may be from ionic bond, coordinate bond or a covalent bond. Okay, coordinate and covalent will be in the same condition, same formation by the way. But we can discuss about generally the ionic compounds. The ionic compounds are very fast during our reaction because the reactions are very instantaneous, and that is the why the rate of reaction generally cannot be evaluated for ionic reaction because of so instantaneous rate of reactions occur. Generally the rate of reaction can be evaluated for the moderately governed reactions, average rate of reactions. If the reactants combine together so fast as in the ionic compounds, the rate of reaction cannot be easily calculated, and that is why the concept of rate of reaction is generally for a covalent molecules. So nature of reactants that will be actually explained in the terms of ionic compounds will be there or covalent compounds will be there. For ionic compounds, rate of reaction will be so fast and cannot be evaluated easily. For covalent molecules, the rate of reaction can be generally evaluated as slow or fast or moderate. Okay? Size of reactants means the particle size will be smaller or the larger. As we know, the smaller particle has a great surface area. The smaller particles has a greater surface area, so there will be more possibility of the collision, adsorption or frequency of collision, of course. That is why the size of reactants also matter for the rate of reaction. The smaller size of particles during collision can be more frequent and will increase the rate of reaction. But when we have a large size of particle, it will have a lower surface area, so that will decrease the frequency of collision, the rate of adsorption during a combination of the reactants particle, and that will decrease the rate of reaction during the process. State of reactants indicating the reactants are in the solid phase or liquid phase or gaseous phase. It is believed that the kinetic energy and thermal energy is generally very high for the gaseous molecule, and that is why generally the reactants when are in the gaseous phase can be combined or can be collide more frequently comparatively than a liquid or a solid. This is the reason why the rate of reaction is generally very high in the condition of gaseous particles, not in the liquid or the solid particles. So the state of reactants determining the rate of reaction will be generally very high for the gaseous particle comparatively other state. Concentration of reactants, as I discussed here with the help of graph, as the concentration of reactants are greater or very high, the frequency of collision, as the particles can be collide for the making a bond, will be greater. Because when the concentration will be greater, it will be more frequency of the collision of the particle that will give a result, a positive result for the production of the product, and will increase the rate of reaction very frequently. So concentration of reactants will be a major product to decide a rate of reaction. Solvent actually decide the reactants are generally combined together in the liquid phase, and in which there will be a water, acid, base or any polar or non-polar solvent. It is believed that if the covalent molecules are polar, it will be more easily to break their bond in the polar solvent. So there will be more frequency of the making a bond and dissociation of bond in a polar solvent. At the same time, if the compounds, if the covalent compound is polar, it will not be easy to break their bonds in a non-polar solvent. So the solvent nature, polarity or non-polarity, will decide the dissociation of bond and association of bond formation. Also, water molecule cooperate or help out during the bond formation by the hydrogen bond. So it will be more easy to solvent the salvation or hydration of the particles in a water because of the hydrogen bonding, because of the polar nature of water. So solvent is one of the most important category that will affect the rate of reaction. Temperature. Class, as we discussed most of the process, the temperature actually decide the frequency of collision. It is believed that with the many experimental data, with the increase of 10-degree temperature, the rate of reaction become nearly double. The rate of reaction become nearly double, and it can be explained on the basis of Maxwell-Boltzmann frequency distribution curve. Maxwell-Boltzmann actually given experimental data with relate of the concentration, average velocity, root mean square velocity, most probable velocity, temperature, and these data together calculate how the temperature is very supportive for a frequency of collision. We all talk about how the particles of reactants collide together to give a desired product. And for the collision, it is very important to determine at which temperature the things are going on. We are knowing about the temperature, with the increase of temperature, it will be more easy to get a more kinetic energy and thermal energy that will increase the collision of the particles at a given state, and because of that the rate of reaction will be high. So with the increase of temperature, it will be a more rate of reaction. For a gaseous species, generally for the gaseous species, the pressure is a very important factor. A pressure is a very important factor. We are knowing about how, because with the increase of pressure, there will be a more concentration of the gaseous species together that will give a more condensation, more compressibility, compression, not compressibility, more compression on the gaseous species, and that will give a more collision of the particles together at the given state. So with the increase of pressure for the gaseous species, the rate of reaction will be high. Now, radiation. Actually, many of the reactions are light sensitive and radiation sensitive. All those reactions which are radiation sensitive always may be affected by the different types of radiation, their frequency and wavelength. If the reactions are light sensitive or radiation sensitive, so the increase of intensity of radiation, for suppose gamma radiation, X-ray radiation, ultraviolet radiation, will affect the rate of reaction differently. Many of the reactions occur in the visible range. Some of the light sensitive reactions occur in the ultraviolet range. So that will affect the reaction rate of reaction differently. And the same pattern, the intensity of light. Here I'm talking about some of the reaction can be depend upon at which intensity the reaction going on. For example, violet light, blue light, green light and red light having different rate of reaction for the photosynthesis reaction in the plants. This is one of the chemical reaction occur during the plant. So the photosynthesis process can be affected by the intensity of light. The same time, you are knowing about many of the photoelectric process also, and photosensitive light reactions also. The light reaction may affect by red light, blue light, green or violet light. That will decide the intensity, the different intensity of light. And in the last, the major factor is catalyst. Students, catalyst just affect the rate of reaction, means increase the rate of reaction in the case of positive catalyst, or decrease the rate of reaction in the case of negative catalyst because the lowering of activation energy. Look at the graph here given. Potential energy, course of reaction. It is observed that during collision of the particles of reactants, they just form a complex formation at excited state. At excited state, there is a formation of complex. This is called a complex formation. Suppose M. This energy point is called energy barrier. Reactants after collision they excited and form a complex at a particular energy value called energy barrier value. Without crossing that energy value, the reactants cannot be converted into the product. During conversion of product, the energy always decrease. During conversion of product, the energy always decrease. Okay, it is mean when there will be collision of the reactants particles, they first excited and will form a complex formation called intermediate complex formation at energy barrier value. So you can see this energy barrier, all those reactants after collision, when they will cross this energy barrier value, can only convert into the product. Okay, all those reactants with that cannot be crossed this value and will not convert into the product. Actually, this catalyst having the role to change their energy path. To change energy path means when we are using the catalyst just provide a surface for the reactants molecules and reactants molecules adsorb on the surface of the catalyst. That will give a smaller energy path and that energy barrier will decrease. Look at the possibility. Actually, without altering the reactants and product, without altering the equilibrium, without altering the path of conversion, the catalyst just decrease the activation energy value. This is called EA, activation energy value. That is important to conversion of the reactants into the product. But you can now see that when we are using the catalyst, this energy value, the activation energy value decreased to this extent. And because of a smaller energy value, more and more reactants will convert into the product. More and more reactants convert into the product. Means the using of catalyst decrease the activation energy value and will increase the production of product, and that will also increase the rate of reaction. You should learn that without altering the equilibrium position. Means if there is equilibrium reaction occur, the rate of reaction of forward and rate of reaction of backward both will increase with the same extent and equilibrium will not be altered. The equilibrium position will not be altered by using the catalyst. That's why the catalyst will increase the rate of reaction by just lowering the energy path called activation energy value. Okay, so this is the one of the most important factor we are having here. These 10 factors at least we have to be decide to learn how the rate of reaction can be actually altered, can be affected, can be influenced by them. Okay, this is all about the theoretical approach of rate of reaction and the factors governing to them. Now we are able to learn about the rate law, order of reaction, the experimental data and observation of the rate of reaction, and molecularity and integration of the same equation. So from next lecture, we'll try to discuss about how the rate law will govern the rate of reaction, what is the order of reaction, to which factor and concentration of the reactant that will decide the rate of reaction, what is molecularity and order of reaction, what is the integral equation of the rate of reaction, and some numerical based on that. Will in the next lecture. Okay, bye.